Let's do this. Today's 9/6. And I believe the name of the worksheet today, I'm not looking right at it, but I think I named it something like simplify before solving. So that's what we're going to call our notes today, is simplify before solving. So today, I hope today goes well. How well today goes really will determine so much about how well the rest of the school year goes, because we now introduce equations where our first thought is not, should I add 5x to both sides, or should I add 9 to both sides, or something like that. Or I have to sort of train into you now today that your first thought, it has nothing to do with solving an equation. So that may sound crazy, but here's your first example. And honestly, I messed up yesterday when I was making your assignment, and you might remember problem, I don't know which one it was. There was 6, that one that had the X's on the same side. So that was sort of an accidental sneak peek at what we're talking about here today. So it was one of those accidents that wound up serving a decent purpose, perhaps. What's that? Yeah. So here's an equation that is every example today, there's only 3 of them, are going to fit this mold of what the notes are called, simplify before solving. So what I have to train out of you today is, if you're even remotely looking at this and thinking about adding 5x to both sides or something, I have to try to work that out of your brain. So what we're going to look at starting now is that the equation consists of an expression on the left side and an expression on the right side. And we always want to simplify each side as much as we can before we begin the solving process. And the solving process is where we start to collect the x's like we did yesterday. Collect the x's on one side and collect the numbers on the other side. So we hold off. So what we think about is, if we just look at the left side of the equation, and I mean just the left side, is there math that I can do locally right there? There is. So this is not fancy algebra math where I have to like put a little minus 3x underneath or a plus. This is not that. This is just old school combining like terms. So I look and I say, hey, you, Mr. 3x, can go with him, Mr. minus 5x. And what is 3x minus 5x? So we are going to put those together, negative 2x. And then, of course, the minus 4 has no one to go with, because if we only focus on what's underlined in red, we see that there are no terms that he can go and combine with, like such. So the left side, we now say, is fully simplified. We agree? Let's head to the right. And so now my focus switches to just the right side. And again, I'm looking at that tunnel vision just as an expression. It's not an equation. It's just a chunk of math junk that I've got to fix up and clean up. What do you notice on the right side? Negative 6 and negative 10 are like terms. Those are called constant terms. They have no x's. So I personally like to put my x's first. You don't have to. So my first thing is, I'm going to take the plus 4x and copy it down without the plus sign, because it's just a positive 4x. And I'm doing that because he has no one to go with, right? What is the, like Cruz said, what is the negative 6 and the negative 10? And I put them together. Negative 16. Very good. So what we find is, like, every day I teach you something, we do one extra little bit of work, 1 or 2 extra steps, and we find ourselves, oh, we're back to where we were yesterday. So now we're back to a standard 3-step equation. So this is a nice 4-stepper. We just did 1 step, and you can see now the 3 steps. 1 step is bringing the x's across, the next step is bringing the numbers across, and then the last step is dividing by whatever winds up stuck to x. So starts to feel really like regimented, like over and over again. Which x should we move? Definitely the negative 2, because he's smaller. And remember, the 4 and the 16 are dead to us. We're not even looking at them. We're focused on controlling the x's. So we're going to add that 2x to both sides, like such. Then we're going to cancel and we're going to drop. So I'm going to drop down my -4. It used to be called a -4, but when you get rid of what's in front of a minus, it transitions into a negative. So now it's -4 equals how many x's? Good job. And now we're down to only 2 steps to go. We are going to add 16 to both sides. Perfect. Drop 6x, drop the equals. Basic math, what's -4 plus 16? 12. It is 12. But, I guess I'll finish first, then I want to point something out to you. Let's divide both sides by 6 while we're here, right? Divide, and then let's, boom, call it good. So x equals 2. Almost all of you have gotten this memo, but I just really want to point out to you, pay attention to that equal sign. And look at the way it basically just transitions in a straight line. It's not straight, but it's vertically oriented. There's no mad scientist scribblings often. It's just straight down like a laser cutter. Any questions about that? Right. My next 2 examples just get progressively more difficult, just meaning that there's a little bit more prep work to have to do before we can start actually solving the equation. So I did not box that one up, but I feel pretty good about it. So I'm just going to let it go. 10 minus the quantity 3x minus 5 closed quantity equals -2x plus 4 times the quantity x minus 2 closed quantity minus 7. We reach a point usually about now, early mid-September, where when things go well, I cannot stump you with equations anymore. I can't. I could make these as long and obnoxious as I want. And if your skills are solid, if you know all the fundamentals, you know how to distribute negatives, you know how to combine like terms, you understand your fundamentals, I could make a 7-step equation and it's still just more work, but it's not necessarily anything that would stump you. That's the point we're getting pretty close to right now. So what is step 1? Let's focus all of our efforts right now on just this left side. What are you thinking? We got to get rid of the parentheses. And since I can't really order of operations, quote, do the parentheses, how do I get rid of the parentheses? That D word. You have to distribute. And what number, don't say 10, what number is attached to the parentheses? Negative or -1. One of the most common errors I see on this side of the desk is kids take that 10 and they're like, oh, I don't see any other numbers, so I'm just going to multiply everything by 10. That 10 has nothing to do with the parentheses. If you absolutely want to see a number in front of the parentheses, let me add one for you. Boop, there he is. I don't normally do that, but you need to understand that the -1 or the negative sign is what goes and bebops through the parentheses. So the first thing I'm going to do is copy the 10 down because he's got nothing to say about what we're about to do. Now, when you distribute a negative, what basically happens to everything? They just change. I don't like it when people say they become negative. That's a terrible answer. They change. That's generalized way of saying negatives become positives, pluses become minuses, minuses become pluses, so on and so forth. Everything just changes. So what becomes of this 3x right here? He's now minus 3x. And what becomes of that -5? Just like that. All right, let's head over and focus on the yellow side. Again, what's our focus? Parentheses. It's not parentheses. It's going to be a long year. It's got to be get rid of the parentheses so everyone's free to move about the cabin. I feel like I can take this -2x and copy it down. And I feel like I can also take this -7 and copy it down because they don't get to play in this step. They're just like hanging out, waiting for us to do our thing. Who's being distributed? The 4, and he's a positive 4, so we don't have to worry about sign switchology this time. What is my 4 going to do to the x? So plus 4x, and then what's my 4 going to do to that -2? he's going to buff him up to a -8. Good. So in the last example, this is where we would have transitioned now into solving mode, and we'd start talking about adding the 2x to both sides and this and that. We're not ready for that yet, because if I focus my energy still on this red side, I'm not ready. I'm not moving into that phase until I'm done with all this. What do you see on the left? That's what I see. I see that the -3x, this guy, has no one to go with. So I, again, I like my x's first. You might form different habits. I'm going to copy him down. And then my 10 and my +5 are going to make. I look at that side and say, all right, you're ready to roll. Let me go take care of this other side now. This is always the goal, is to get to this crossroads. Left side clean, right side clean, then we solve. Can you tell from sitting here how many steps this equation will have taken when we're done? 5. Whenever I'll show you in a second. Let's finish and then we'll have that conversation. This right side has 2 pairs of prom dates, right? So like the x's can go together. What's -2x's plus 4x's? 2. So I'm going to bring my x's first as +2x. And then I'm going to put my constant terms together. My -8 and my -7 make -15. Whenever you get to this point right here, you can always think to yourself, there's 3 steps to go. That's just a standard looking 3-step equation where variables moving is 1, numbers moving is 2, dividing is 3. So that's the crossroads where you say 2 down, 3 to go, 5 move equation. Who should we move? Which x? Definitely the -3. For God's sake, he's smaller, right? So we're going to add 3x to both sides. We're at that point. Now it's time to start moving things across, letting the sides of the equal sign interact with each other. Cancel the 3x's, drop, drop. So we're going to bring down the +15 without the positive sign. Bring down the equals. What's 2x plus 3x? Bring down the -15. 3 down, 2 to go. Next step. Add 15. Bring down the 5x. Bring down the equals. 15 plus 15. Indeed, 30. Last step. 5 steps down. None to go. Cancel out your 5s. X equals 6. Math is kind of neat when you take that. You don't have to. As I said earlier, I don't do this as like a thing we have to do, but it's kind of neat if you actually take the number 6, which you claim is your answer, and you go put it right back where these green arrows are, right there, and right there. It's like witchcraft. You put the number 6 in there and you go 3, 6, 8, 2, 5, 13, 10, and you put it and you're like, oh my God, the left side equals the right side. It's really cool that actually works that way. Algebra is pretty cool like that. Any questions on example 2? How's that? Okay. One more and then it's work time. And I thought I would tell you this while we got a catcher-upper on the notes over here. Your first quiz in my class, just for your mental preparation, is Tuesday. My plan for you guys is that tomorrow we will do our first, what we call a practice quiz. I will always give a practice quiz. They're really important. We will go over the practice quiz just like this in class on Monday, every question step by step, and then your quiz will be Tuesday. And for those of you who like to plan and get things ready, does anyone remember about notes for the quiz? What I said on notes, Addie? What about the front? Can I do front and back? You can. And you can put anything on that standard size piece of paper that you want. It can be examples. Sometimes people write thoughts. Like if I'm someone who frequently messes up, like forgetting negatives, I might put a little comment in like hot pink, like, hey, don't forget to put negatives, or minuses, drop them as negatives. Or some people just cover their notes with examples. Some people cover their notes with like rules of addition and subtraction and times table stuff, and two negatives when divided make a positive. The notes should be your creation, and they should be catered to what you need. If Addie's notes look exactly like Rutley's notes, I mean, what's the point? Because they each have different needs, right? So that's something that you should not be preparing Tuesday morning at 7:45. Like, well, bro, let me see your notes. Like, they're his notes, dude. Like, what, they're not gonna help you. So you should start thinking today and tomorrow about every day, add a little something, something to your notes. When you reach a problem that's really hard, add it to your notes, right? And then you will be turning in your notes with your name on them, with your quiz and your practice quiz, FYI, on Tuesday. So I know that's, what is that, 144 hours away still, 143 and a half hours, but I thought I'd give you time to mentally prepare. All right, last exam. Put that anywhere. -4 times 2x plus 4 minus quantity x minus 3 equals 5 minus 2 times the quantity of x minus 5 plus 3 times the quantity of x plus 4. That looks like a lot of work, right? That you look at that and think to yourself, there's no way I would have been comfortable with this 3 or 4 days ago, right? But now you're fine. I say I can't make these harder per se, just make them more, what's the word, like annoying, I guess, like more stuff to do. If you have good basic skills, I can't stump you. I can't. Algebra is going to come back to, can you multiply well and can you add and subtract well? And if those things are in place, you cannot get below an A or a B in my class or any math class. Basics. So let's do this. The left side is a whole bunch of stuff, and that is our focus right now, is we're going to take this left side and we're going to look at nothing other than that. What do we do first? Get rid of those parentheses by using multiplication, distribution, right? Remember, distribution is just fancy multiplication. So we have double distribution because there's two sets of parentheses. So we have two distributors. That's okay. What's being distributed in the first set? Let's do this. So help me with my distribution. What are the two answers to those distributions? Mm-hmm. Yep. -16. And that's something that I would add into my notes personally is, and you may not need it come Tuesday because like you will have practiced it so much that maybe you'll get it straight. But I know from this side of the desk, I take off hundreds and hundreds and hundreds of points every year because people forget that when there's a negative number outside parentheses, it swaps the signs of all the things when it hits them. I'd add that to my notes. I'd at least make sure I have an example of it. Who's the second distributor? He's just a negative or a -1. You can call him either one. So when that negative sign distributes into the second batch, what do we get? -x, say it, plus not -3. You can't have it both ways. Once you commit to changing that minus to a plus, you're done. Just put 3. The -3 says, I'm going to change to a +3 because you smacked me with a negative sign. End of story. So that is a story not quite fully written. We'll come back to that. Let's head over to the yellow side. And this time, who does not play in step 1? The 5. I would tell you it's a good idea to just take it right now and copy it down because you don't want to do something knuckleheaded like put 5 minus 2 and put a 3. That's just flipping the bird at the order of operations right there. You can't do that. That 5 has to wait his turn. So who's distributing into the first set? -2. And when that -2 smacks dudes, what's he going to do? He's going to change them all. If they're positive, he's switching them to negative. If they're minus, he's switching them to plus. They're positive, switching them to negative. Everything can switch. So what is our first distribution answer right here? Yeah, minus 2x. Good job. And how about our second distribution? Plus 10s. Well spoken. Good job. Pluses and positives kind of feel the same, but when we're inputting them into an expression like this, they are pluses and minuses, not positives and negatives. How about the second distribution? Give me signs. Plus 3x. We need operators always. And then the last one? Good job. And I'm telling you, that right there is a hurdle. When I'm grading a test, if something goes wrong, the first place I'm looking is there, because there's a 90% chance that someone boofed the distribution. So good job if you survived that hurdle. Now let's focus on the left side still. Red underlined side, not done. What do you see? I got some x's I can put together. Negative 8 x's, and then another negative x or a minus x, whatever you want to say. How many x's is that? Negative 9x. I also see some constant terms. A negative 16 and a plus 3, basic math. What's negative 16 plus 3? Negative 13, left side, done. You will rarely find any instances when you can't do all of your cleaning work in 2 steps. The only exception will be after this first quiz when we start doing equations with fraction killing. Then the first cleaning portion can take 3 steps or so. On the yellow side, I know you're getting fidgety. This is taking longer, but it always does. We're almost done. On the yellow side, the right side, I see some x's. Let's put them together. How many x's will there be? And what is negative 2x plus 3x? Just x, right? 1x, just x is a better habit. Putting ones places is like, don't do it. Kind of weird. I see 3 constant terms. I see 5 plus 10, which is 15 plus 12, which is positive 27. So I'm inputting a plus. And as advertised, I'm telling you, this is the crossroads that you get to, where you go, okay, autopilot, move the x's, move the numbers, divide. It's like snooze fest over and over again. Which x should we relocate? Let's say again? The negative 9x, right? I'm sorry, I didn't hear the 9 part of that. So let's do that. Let's add 9x to both sides. And again, we're picking on that because he's smaller and we want to keep our x number positive. So we're going to cancel, drop, drop. What are we bringing down on the left? Negative 13. How many x's? Nice. Next step. Yeah, you guys are starting to get on autopilot mode, so this is good. Starting to just feel like we just know what to do. Good job. And I think the vast majority of you are really embracing this neatness idea. Work down, 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 down. Laser beam that equals sign straight down. Drop your 10x, drop your equals. What's negative 13 minus 27? Definitely negative and definitely 40. Remember that when you start with a negative and subtract, you're really just adding downwards. It's 13 plus 27 with a negative sign on it. That's all that is. Last step. Divide by 10. Cancel, drop, drop. And woof, that was a lot of work. But you're not allowed to try to tell me that was really quote unquote hard. It's just a lot of work. There's a difference. So that concludes the lecture part. Your assignment is popped up as you would expect on Canvas. I'd like you to get it done today/tonight so that tomorrow we can focus our energies on just quick grading this assignment and then get hammering on that practice quiz. Because tomorrow's the last school day of the week, unless I see you for Friday schools. What I'm telling you is this assignment is due tomorrow. What did you call me?